Welcome to Molecule Monday on Curly Carbocation. If you like short form chemistry content, please subscribe and stay tuned. Last week I talked about the 3 classifications of acids and bases on Molecule Monday, and last week's Organic Odins Day, I brought up something called the pKa. pKa stands for the negative logarithm of the Ka value, and Ka is the dissociation rate of acids. And this also applies to bases. Letter P stands for negative log, just like in pH is this negative logarithm of the concentration of hydronium, and pOH would mean the negative logarithm of the concentration of hydroxide. Now you're gonna have to check out my other channel, Curly Calculus, for why we use logarithmic scales. But why we use negative log, I don't know. Chemistry, we use K to talk about the rate of the reaction, and Ka is the dissociation rate of the acid. Very simply, K equals the concentration of the products divided by the concentration of the reactants. But we also have to take into account the coefficients within their balanced equation. Let's take this generic balanced equation for example, noting that the lowercase letters are the coefficients, whereas the uppercase letters are the actual reactants or products. Replace the lowercase with numbers and replace the uppercase with molecules. First things first, identify your products. So the products are on this side of the arrow and the reactants are on that side of the arrow. And K equals products over reactants. So the rate of this reaction equals the products over the reactants, or the concentration of C raised to little c times the concentration of D raised to little d, all over the product of big A raised to little a times the concentration of B raised to little b. Now that we have the generic model, let's take this one into account. Keep in mind that the coefficients of sodium sulfate and sulfuric acid are both 1. That ends up being NaCl squared times H2SO4 to the first power, all divided by Na2SO4 to the first power times HCl squared. Knowing that the Ka is the rate of dissociation or the rate of reaction, and then that the pKa is the negative log, this is what it would all equal to. Of course, if you're doing this in a calculator, I would rather that you solve for the Ka first, take that value, and then take the negative log of that value. And considering that example we had, this is what the pKa would look like when solving for this particular reaction. I'll let you guys take a screenshot. If you like this video, please be sure to share this with someone that you know is gonna like this. And I will see you all tomorrow in Teacher Tuesday. Bye guys!